My name is Toyibat Adele, although I prefer Adele, but I'm a 300 level mechatronics engineering student during the day, and I am a machine learning engineer when I'm off the clock from school. When I'm not pursuing my passion for technology, you can find me in a book, living in another world far from reality. And I'm very committed to using technology to solve global challenges in the little way that I can. Okay, so this is our agenda for the day. First of all, I will introduce my topic. We're going to understand virtual environments. We'll look through popular virtual environment tools. We'll see how you can enhance your coding workflows with virtual environments. We'll see how to best structure your projects and best practices for your coding workflows, and then we'll have a small session for question and answer. I figured this thing out. Okay. Introduction. Okay. So this is a picture of an office. And in this office, there are many desks, many gadgets, computers, CPUs, whatever. And each person has the role that they play. So on this desk, they have the tools that they require to get their job done. On the computer, they have the different softwares that they use. So we're going to use this analogy to explain what virtual environments are. So in this situation, the virtual environment is where each person is working and the tools that they're using to work. So a virtual environment is basically a folder on your PC that lets you manage whatever you need for a particular project, so it doesn't clash with your global installations on your PC. So coming back to this example, you can't have everybody work on one computer. Number one, for efficiency purposes and because they all have different requirements for their roles. So a virtual environment lets you have what you require for a project in a particular environment that you can work on. So why is this important? I have one word for you. Okay. And that word is ease. Yeah. So virtual environments make working with Python very easy. And it also prevents you from doing this to your PC out of frustration. Okay. I don't know. I'm having issues with this. So yeah, next we are on understanding virtual environments. And we are still referencing our photo from earlier. So this is a short definition. Python virtual environments are separate folders with their own Python setup and packages, keeping them isolated from other projects, like I said earlier. Okay, so this is an example of how you can use virtual environments. Say on your PC, you could have an environment where you have beautiful soup installed with this version of pandas and this version of NumPy, and then on that same PC, you could have another folder with TensorFlow, Selenium, Matplotlib 2.0 installed, so that you can work on a particular project that involve these dependencies and they don't clash with each other due to versioning issues and stuff like that, of different versions, I mean. More benefits of using virtual environments are these. The first one, it ensures that your project is conflict free. So what this means is that each project operates in its own virtual environment, preventing conflicts over shared resources. The second is consistency. Developers can recreate the exact working environment needed for their project, ensuring consistency and reliability. Finally, organization. Dependencies are managed within each virtual environment, keeping projects organized. Oh my goodness. Okay, yeah. So now we're moving on to popular virtual environment tools, and there are four very popular ones. I don't know how this thing works. Okay, move fast. Sorry. Okay. So the first one is VMV, the second one is Conda, the third one is Poetry, and the fourth one is PeepEnv. Okay, so now we're going to go in depth into what VMV is all about. Okay. So VMV is Python's built-in tool to isolate projects. So with VMV, you don't need to make any extra installation besides the virtual environment, the packages I mean that you want to work with, or maybe updating VM, but it comes default with Python. Okay. So these are two benefits of using VM. The first one is that it is easy to use with minimal setup, and the second is that it is ideal for smaller projects or quick setups. Okay. So these are some common commands you use to navigate VM. The first is the Python -m VM quotation mark env. Thank you. So what this does is it creates a virtual environment called env. So when we have env there, you can replace it with any name you wish to call your virtual environment. Next, this is how you activate your virtual environment on Windows and on Mac. So for Windows, you use the /env /script /activate to activate your virtual environment. But then for Mac, you use source space env /bin/activate to activate your virtual environment. So to install packages in your virtual environment, you use the pip install package command, and you replace package with the package that you want to install or the dependency. You can also add the particular version after the name of the package to install a particular version that you want to work with. And then next is pip list. So this shows a list of all the dependencies / packages that you have installed in a particular virtual environment. And if you want to put those together so that someone else can work with those packages and recreate the environment that you've created, you run the pip freeze space greater than requirements.txt. So it puts all this together in a requirements.txt file. And then when someone has that requirements.txt file, they can just install those dependencies using pip install -r requirements.txt. And then finally, to deactivate this virtual environment, you just type deactivate, and you do all this in your terminal. Actually, I forgot to mention that. Yeah. So are we good? I hope we are. I hope that made sense. If it doesn't, you can ask me any question you have at the end of this. So the next is Conda. And Conda is an open source environment management system. So with Conda, Conda is not just limited to Python. You can actually create virtual environments for multiple languages with Conda, and that is one of its unique features. So benefits of using Conda: it handles complex dependencies and large-scale data science libraries, and it is suitable for projects involving multiple programming languages and tools. So you have to install Conda before you use it. It's unlike VM that comes with your Python installation. So to install Conda, you can either download Anaconda or Miniconda. Just search for this in your browser, and the link to download it will come up, or the link to the website. Then you install the software, and you make sure to add it to path. If you don't, you will not be able to recognize it on your terminal unless you do this manually. And then finally, you can confirm the installation by running Conda space -- version on your terminal to see the version of Conda that you have installed and if it was successful. Okay. Fast. Yeah. So like before, these are some common commands that you use to navigate Conda. The first is Conda create --name my env. So this command helps you create a virtual environment, and you replace my env with the name that you want to give that virtual environment. It could be anything, honestly. And then to activate this virtual environment, you use the conda activate my env command. So this activates your virtual environment and you can start working in it. So to install packages like vmv, where we use pip install package, here you just use conda install with the name of the package and also the version if you have to be very specific. So next, conda list shows a list of packages that you have installed in that virtual environment. And like before, if you want to put this together how do you pronounce that word? Yeah, to ensure that people that want to work on that project can easily reproduce it, you put this command or you use this command, conda env export greater than environment.yml. So it puts this in the environment.yml folder, and then the person that wants to work with it can just use the conda env create dash f environment.yml to install those dependencies. But if the person is using a different virtual environment platform, you could just do conda install pip and then pip install requirements.xt. So no, actually, you do conda install pip, and then the command we had from before, which was pip freeze greater than requirements.txt, you can use that to put it in a requirements.txt folder as well, or file, I mean. So the person can just use this command to install it. And then finally, you deactivate the environment using conda deactivate. Okay, yeah. So are we still good? Okay. So the third one is poetry. Now, poetry is an open source tool that simplifies managing project dependencies, but then this is strictly for Python. I don't know if it works for other languages. So benefits of using poetry. It handles dependencies, virtual environments, and packaging in one tool. It also ensures consistent environments across development stages. So these are some common commands to navigate poetry. The first one, you have to install it, and you can do this in your terminal. So you pip install poetry, and then to create a virtual environment, you just run poetry shell. And next, to install a package in your environment, you run poetry add package. And like before, if you want to be very specific, you can add the version number as well. Next is poetry show. So this shows a list of the packages that you have installed in your virtual environment. Dependencies are automatically added to the pyproject.toml file. So each time you add a dependency or a package or you uninstall it, this is done automatically in the background, so you don't have to manually push the dependent or freeze the dependencies in a list like earlier. And then next, poetry install. So if you have this pyproject.toml file, you can just run poetry install, and it installs the dependencies and automatically creates a virtual environment for you. So to leave this virtual environment, you just run exit. But then you have to run poetry, oh, not that one. Actually, that's for ppm. Yeah. So to permanently delete an environment, you run poetry env remove with the environment name after remove, and then it automatically permanently gets rid of this virtual environment. So yeah, thank you for still being with me. So the next one is pipenv. And then pipenv actually combines pip and virtual env to provide a dependency management solution, like the other ones. So benefits of using pipenv. It ensures consistent and reproducible environments with pip file and pipfile.lock. And next, it simplifies the setting up and management of virtual environments. So like before, these are some common commands that you can use to work with pipenv. Firstly, like with poetry, you have to install pipenv, and you do this by running pip install pipenv. They have it's very similar to poetry, honestly. So the next command is pipenv shell. So it creates a virtual environment for you. Pipenv install package installs the packages that you require in your environment. Pipenv graph shows all the packages that you have installed in that virtual environment. Like with poetry, dependencies are automatically added to the piplog file, so you don't have to do it manually most of the time. But then if you want to create a requirements.txt file for someone that wants to work with this, you can just do pipenv lock-r with the greater than sign requirements.txt, and it puts this in a requirement.txt folder. So if you already have maybe the piplog file, you can just run pipenv install, and it will install all the dependencies for that project. And you can just use exit to exit your virtual environment. Thank you, but we're not done. So this is a comparison of venv, conda, poetry, and pipenv. So deciding on a Python virtual environment tool is very overwhelming because there are numerous options. There are many more options beyond what I've already mentioned here. So I have a small table that will just help you make that decision-making process easier. So this table mentions the tool, key differences, advantages, disadvantages, and the best use cases of each of these virtual environments. So the first one is for VM. And well, a key difference is that it's a built-in Python tool, so you don't have to install any extra software or anything. It is very lightweight, but then it is limited to only Python. And then its best use case is for simple projects that don't require a lot of complex dependencies. The second one is Conda. And a key difference of Conda is that it's multi-language. So if you have a project that's running on not just Python or Python libraries, Conda is your best bet. And its advantage is that it handles complex dependency management. So like I said, for a project that requires heavy duty dependencies, you can also use Conda to work with that. But then Conda has a large installation size. So if that is not your cup of tea, you might have to look at something else. But then Conda's best use case is for data science projects or machine learning models and all of that. So the third one is Poetry. And its key difference is that it handles integrated dependency management. So what this means is, like before, where I stated that it automatically adds your dependencies to the pyproject.toml file. So it's actually very strict. So it logs this down to the version. So it ensures like strict consistency across different virtual environments and in a team. So if you're working with Poetry, it just makes the environment like it is very, what's the word now? Actually, it's, I don't know, it's very, let me not say rigid, but it's I actually don't know what word to use for it, but it just ensures that every single thing down to the atom is consistent across different environments. If you're working with something like VM now, on your maybe in your requirements.txt file, you might not mention the version that you installed, but then with Poetry, it's very detailed. I think the word I was looking for was detailed. So it's very detailed down to the version number, down to all those intricacies that you might require. But then a disadvantage of this is that it has a steeper learning curve than the rest of them, so you might have to look out for that. And then its best use case is for a project that requires very detailed dependency and packaging management. So finally, we have pipenv. And a key difference of pipenv is that it combines pip and virtual env. A key advantage of this is automatic virtual env management. But then a disadvantage is that it can be slower than the rest of them. And the best use case is also similar to Poetry, where it can be very detailed down to the nitty-gritty of what you require. So the fourth section is on enhancing coding workflows with virtual environments. How to enhance your coding workflows with virtual environments? So first, you make sure to set up a virtual environment within your project. Next, you make sure to work in this activated virtual environment and install your dependencies or packages as you need them. So next, you install the requirements file. So this lets other people that want to work on that project know what they need to work on that project or to ensure a consistent environment all around. Next, you make sure to run tests in that virtual environment so that it's consistent across board. And it's not as if maybe you have a different package behind the scenes that's making everything run fine, and then you send it to someone else and it's like, oh, this thing is not working as it's supposed to be. So you make sure to use virtual environments for that. And then finally, you can use environments as a deployment blueprint. So with virtual environments, you can deploy your project and you know how it's going to work after it has been deployed under these conditions. Okay, so how does this help you? First, it ensures consistent environments, like I said earlier. So it ensures all team members use the same dependencies and versions, avoiding the "it works on my machine" issue. So the second, it ensures reproducible steps. So it isolates project dependencies, preventing conflicts and making debugging easier. Or should I even say that? So third, easier dependency management. So it allows easy replication of development environments, ensuring consistency across stages. So the fifth one is on project structure and best practices. So to maximize the benefits of virtual environments, these best practices and tips will help. So the first is structuring your project. Keep separate directories for code, test, docs, and virtual environments. Make sure to use clear and consistent naming conventions like myproject.py if it's for a project that you're working for Python scripts. And then if it's a test file, you can use something like test my Python myproject.py. So it shows that this is the test file for that same project. Also, make sure to include a readme.md file with clear setup instructions, usage guidelines, and project overview. So the third one, the second one actually, is on integrating virtual environments with version control. So you can do this by adding a dependencies file to version control to ensure they are tracked and can be recreated by other team members. You can also use .gitignore to exclude the VM directory from version control to avoid bloating the repository. And then finally, you commit changes to the dependency files frequently to keep it up to date. So third, optimizing workflow efficiency. So you run tests within the virtual environment to ensure that all dependencies are correctly installed and that the code runs as expected. Second, periodically clean up and remove unused environments to save disk space and reduce clutter. So we've basically come to the end. We are in the question and answer section now. Thank you. Okay, so let me just quickly round up. So a brief summary. Virtual environments are important for managing project dependencies. Tools like VEnv, Conda, Poetry, and pipenv help with setting up and managing environments. Avoid dependency hell. Ensure proper documentation so your environment is reproducible. Oh, shit. Okay, so virtual environments are your weapons against dependency chaos in Python. And I hope that after this session, you will have seen the beauty and the usefulness of using virtual environments as opposed to battling dependency conflicts in Python. The meme is supposed to come up. Please hold on. Yeah. So thank you and God bless you.
Questions? Thank you for your presentation. I have just two questions. Yeah. One, network can be an issue in Nigeria.
Yeah, that's true.
Good. You've done a project and you created a virtual environment for it.
Yeah.
Then the second project you want to begin, but network started frustrating you. How can you copy the virtual environment from the previous project and use it in this current project, especially when you're using similar tools or similar versions of those libraries? That is one. Two, I have experienced something doing pip install requirement.txt. Some of the packages were not installed using pip. But when I installed those packages using pip3, it will install. So what's the difference between pip and pip3?
Okay.
Thank you.
Thank you very much. Okay, regarding your first question, I actually have not done something that requires that, so I don't really know how to approach answering that. I actually don't know if just copying the folder and pasting it into it doesn't work. Yeah, so I don't know. I wouldn't recommend that, but I actually don't have an answer to that question. The second, the difference between pip and pip3. I think pip3 is the um is it the updated or current version of pip actually? I don't I don't know. I actually don't know the answer. I didn't account for this kind of questions. You want to ask a question? Oh yes. Yeah, I think you want to help.
Okay, contribution. That was what I was looking for to the questions. So regarding his question, sorry, he mentioned something about the pip tree, right? That was what you mentioned. So on Linux, if you are using Linux, you use pip tree directly because we have Python 2, Python 3. But for Windows, you can use pip directly to do installation and to work. fine. Don't know if you get that correctly. So regarding the transferring one requirement to another environment, it's actually very easy. You all you need is either the toml file, the YAML file, or the requirement.txt, like the actual file that is used to track the dependencies that is installed. Right? All you have to do is transfer it over, activate a new environment, then install the requirements on that environment. So you have all the setup on the new environment.
Thank you.
Yeah,
Though
thank you.
I
I
think
also
what
learned from.
the person asked was that how do you do that offline due to network issues? So if you have contributions for that, that would be really appreciated.
Great talk. So my question is around situations when you are probably working with different Python versions, right? Among the four options that you mentioned, is there any one of them that probably helps in that regard, where you can specify, maybe before creating a virtual environment, you can basically specify the specific Python version? That's it.
Yeah, VM actually helps with that, but I did not include it because I thought it was going to be too much of a slide. But I don't know if you remember the first command I mentioned was Python dash m VM blah blah blah. So after Python, you can actually add the number of the Python version that you're working with. So if it's Python 3, you can do Python 3 dash m and all of that. But if it's maybe Python 2 or like the specific version.
I meant the specific, like for example, you could have Python 3.4, Python 3.8, which there could be a minor change, or maybe Python 3.10. Is any of those libraries that help in that regard? Because there are certain softwares that, for instance, only work with a specific Python version. Again, excluding whether it's Python 2 or Python 3. Do any one of those tools help with that?
I feel like they all do. You just have to install the Python that you're working with in that virtual environment and then carry on with your project. Yeah. No, just once in that particular virtual environment. Yeah, and to be updated. Yes, that's all.
So sorry to, I think she answered. So what she's saying essentially is there are some version like three. There could be 3.9.2, 3.9.3. So when you install Python 2 now, it's just Python. So when you want to run it, so you can say Python, then the script to run it with 2. But 3 is going to be 3 Python 3, no spaces. So if you want to spin off a virtual environment for 3, you can now say Python 3, then the vn dash m then the name of the virtual environment. So when you install different version of Python, it's going to come with the version number. So you just put the version number and then you spin off the environment. So the Python version you use is going to be the one in the version environment, virtual environment. I don't know if that's clear.
So let me just help out a little. I'm sorry, I'm not meant to do this, but so I think the question was that if you have 3.2.9, you have 3.3.10, and then you want to install a software that works with 3.2 point maybe 11. How do you do that? Now you have like three different versions of Python you have to work with for different software. So what you could do, a very good package you could use is PyEnv. So with PyEnv, you could do PyEnv install 3 point version, PyEnv install whatever the version. When you want to work on with whatever version you want to use, you could just activate that particular Python env, maybe globally or locally. Then that particular Python version will be used in that project or globally on your system. Then you can use that to install the virtual environment. Thank you. That's all. So
Thank you.
thank you. Okay, so, like lightning talks.